Good morning, student. Myself Amakshi Thakur, and today's lecture topic is coarse dispersion in physical pharmaceutics second. What is coarse dispersion? It is a thermodynamically unstable compound where the heterogeneous system where the size ranges of particle is dispersed particle is 1 micrometer to 100 micrometers. Dispersed phase is basically divided in two groups. One is internal phase and second is external phase, or either we say that a continuous phase and discontinuous phase also. Internal phase consisting of insoluble solids particle having a range of size 0.5 to 5 microns, which is maintained uniformly throughout the suspending vehicles with aid of the single or combination of suspending agents. The external phase is a continuous phase. It is a generally aqueous in some instance, may be an organic or oily liquid for non-oral uses. Coarse dispersion is basically divided in two main formulations. One is suspension and second is emulsion. We observed this in this lecture. We observed only a suspension formulation. Definition of suspension: it is heterogeneous system in which solid particles is uniformly dispersed in liquid medium. The coarse suspension particle sizes ranges greater than 1 mm. Colloidal suspension, the particle size is less than 1 mm. In pharmaceutical suspensions, it contains therapeutically active particles. Ideal characteristics of the suspension: the suspended molecules should not settle rapidly. They must be easily resuspended by moderated shaking. It should be easy to pour. It should be free from grittiness. It should have pleasant odor, color and palatability. It should be easily flow out from the syringe needle. It should be physically, chemically and microbiologically stable compounds. These are the ideal characteristics of a suspension. Next, system becomes a thermodynamically stable compound. Thermodynamically stable compound कब बनेगा? जब surface free energy equal to the zero achieved करेगा by adding a wetting agent or a surfactants to the suspension. It gives the result in reduction of interfacial tension and interfacial area. Formation of electric double layer. We observe the electric double layer formation by preparation of suspension. If the particle have a range greater than 1 nm is dispersed in water, there will be a reaction between at the solid liquid interface. Both solid and liquid parts carrying different energy levels. Basically, all substances carrying a negative surface charge energy, and once they are dispersed in water, it continues, means it causes a high dielectric constant of water. Media with a lower dielectric constant carry anionic surface charges. Water contains ions of dissolved salts and get attracted by the surface charges. Thus, these ions gather around the particles. A well-loaded and immovable layer covers the surface of the particles. This is called a stationary layer, or may also known as a Stern layer. Zeta potential. The total charge that exists on suspended particles in the zeta potential, or the potential at the slipping line, means a boundary line of the diffusion layer. It is called a zeta potential. If the zeta potential is higher, the repulsive forces will be more than the attractive forces, and particles remain dispersed and deflocculated. If zeta potential can be reduced by the adding electrolytes at particular concentration of electrolytes, attractive forces dominate slightly over the repulsive forces. Particles form loose aggregates and remains of flocculated suspended. At large concentration of electrolytes, the suspension particles get deflocculated again. Deflocculated suspension. Deflocculated suspension क्या होता है? When the particle approach each other, they experience repulsive forces. By creating high potential barrier, it prevents the aggregation of particles and it show a primary maximum sedimentation of the particles very slowly. Second, particles form a close packaging arrangement, means fills the voids between the larger particles. Lower portion of the sediment gets pressed by the weight of the sediment above. This force is sufficient to overcome the high energy barriers. Once the energy barrier is crossed, particles come in close contact with each other and establish stronger attraction forces and formation of a hard cake. This deflocculated suspension and flocculated suspension, it is also a part of a settling in suspension. Flocculated suspension. Particle reduced at secondary minimum. Particles are separated by about 1000 to 2000. Particles are loosely structured, easily redispersed. So here the two formation, flocculated suspension and deflocculated suspension. Stokes law. The settling kinetics in a dispersed system, we used basically Stokes law, which is proposed by the George Gabriel Stokes. Formula is V equals to d square G into rho P minus rho S divided by 18 neta. Thank you.